Hey there, grade 8s. Today we're going to be talking about solving problems involving independent events. So similar to the last lesson where we were talking about how to find the number of possible outcomes that you can have based on independent events or from a couple of independent events. So I've got another example that I'm going to show you in a second where we actually have three independent events. The first one is you're flipping a coin, so you're either going to get heads or tails. Your second event is going to be you're spinning a spinner, which has red, green, and blue. And then your third independent event is you roll a dice. So just because you flip a head in one doesn't mean there's going to be a particular outcome in the second event. So what I've actually done is I've put it into kind of a tree chart so that you can see. And I broke it down. So we have heads, then we have tails. And then from there, you can either spin red, blue, or green. And we have red, blue, or green. And then from there, when you roll your dice, you could get 1 through 6 for each of them. So I actually went down and I wrote down. So you could get heads red 1, heads red 2, heads red 3, heads red 4, heads red 5, heads red 6. And then the same thing with heads in blue and heads and green, all the way 1 through 6. So when I'm looking at it, the way that I kind of calculate what I have is I have 6 outcomes here, 6 outcomes here, 6 outcomes here. And when I go to tails, I'm going to get the same thing. So I'm going to get another 6, 6, and another 6. So basically, how do I figure out how many possible outcomes do I have? Well, most of you probably figured out in the last lesson that what we can do is we can multiply the number of outcomes with one event, which is 2. The number of outcomes, or by the number of outcomes with our next event, by the number of outcomes with our final event. If you have 4 events that are happening, then you would have your 4 numbers. If it's just 2 events, then you would have 2 numbers, the number of outcomes for both of those events, the possible outcomes. And then you multiply them together. So 2 times 3 is 6, 6 times 6 is 36. So we have 36 possible outcomes when we're doing all 3 of these events. So when you're thinking about, okay, well, what are the odds of winning the lottery or something like that, that opens it up because there's 7 possible numbers when you're picking a lottery ticket, but your numbers could go absolutely any way you want. You could have any 2-digit number or 1-digit number in the lottery. So you're thinking about, you got 99 times 99 times 99 times 99 times 99, like times, to the power of 7, essentially. So you're trying to figure out, what's the odds of winning the lottery? Well, it's not very good. But what if we have something else? What if we have, for example, a lady has a bag, and inside of her bag, sorry, I'll try to get away from the glare, she's got 6 marbles. One of them is white, the rest of them are red. Okay? So she reaches in, she pulls out a marble, she sees what color it is, puts the marble back. Okay? She does that 5 times. Okay, so what are the odds of her picking a marble? Well, the odds initially, she has 6 possible outcomes. Okay, and then she's going to do that 5 times. Okay, so it's 1 in 6, 1 in 6, 1 in 6, 1 in 6. So she ends up getting 1/30th that she pulls the white every single time. Right? There's 6, if I want to say, what are the odds of her pulling a white marble once? Well, she has, in any possible opportunity, she has 1 in 6 chance. Okay, so we'd have 1 in 6 times 5, which would give us 5/30, or a total of 1 in 6, right? If we reduce it. So if we were to, depending on how you're wording it, like what are the odds of her pulling it twice? What are the odds of her pulling a white one 3 times? Those are going to change your possible outcomes. So let's look at another example. Okay. Let's say we've got a coin that we're going to flip. So we've got 2 possible outcomes. And then we've got dice. So with the dice, we have 6 possible outcomes. So what are the odds of, let's say, getting a 4 and a heads? Okay, well, heads, there's only one there and one here. Actually, I'll put this on top. Okay, so I'll say 1 and 1. Okay, heads, I only have one option. 4, I have one option. So that would give me 1 over 12. Okay, what if I was to change it? What if I was to say, what are the odds of me getting a heads, but I also want to get an even number? Well, I have 2, 4, and 6, so I have 3 options. Then I do my multiplication that way. So then I would have 3 over 12, which I could reduce to 1/4. All right, so this is how we're actually going to be calculating the probability of a lot of things happening. And this is probably my biggest suggestion for you. Try to turn it into, to get your fraction, is you're going to say your desired outcomes on top, and then your total outcomes underneath. Because your desired outcomes are going to be your numerator, and your total outcomes are going to be your denominator. So when you break it down, you're going to end up multiplying however many possible or desired outcomes that you have. That will become your numerator. That's to make sure that your experiment is successful, and then total outcomes is going to be on the bottom. So if you were to calculate the lottery, for example, if I was saying you'd have 99 times 99 times 99 times 99 times 99 times 99. Right, and then on top you're basically gonna have 1 times 1, because you can have one number for each of them, but you never know what they're going to be. So like I said, the odds are very, very against you in that situation. But there's a lot of other outcomes that can work out in your favor. So once again, complete the Google form. Do your math make sense? Section 7.4. If you have any questions, bring them to the Zoom chat. And this is actually the end of the chapter, so hopefully you can ask any questions that you might have. Let me know if you have anything or you need help with anything. Okay, good luck.